Oh! Hey everybody, welcome back to another video. Today I'm going to show you how I built this flamethrower for under $150 using hardware store parts and scraps, and then we're going to go out to the desert and shoot it and have some fun. Building a flamethrower is a fun activity, but inherently dangerous. Make sure to check your local laws and statutes to see if it's legal in your area before building one. Additionally, this is not an exhaustive tutorial, this is just how I did things. Therefore, I am not liable if there is injury or damage caused by a build of your flamethrower. This is purely how I did things, this is not a tutorial, but with that out of the way, let's get going. Now, most of the parts in this video that I used to build this flamethrower, you can actually buy at Harbor Freight or your other local hardware store. There are a few things that you may have to order, but generally the idea with this project is to keep it as cheap as possible and to keep it as accessible as possible to anybody who might want to build one themselves. To start off this project, the main tank that everything is built around. Here I'm using a oxygen bottle used for an oxyacetylene torch, but you could just as easily use a fire extinguisher or a propane tank. The important thing to note is that it is rated for a pressure far beyond what we will be using here, and it has walls that are thick enough we can drill and tap to put our fittings directly into. For this project, all the fittings are 1/4 inch national pipe thread. You could use a different diameter to get a better flow rate, but for this project, I just went with 1/4 because it worked for me. In this video, we're going to be shooting an 80-20% mix of gasoline to diesel. Diesel is very important because it lowers the volatility of the gasoline. Shooting pure gasoline is incredibly dangerous. If it builds up vapors in the air, it can explode. Using diesel also allows us to get a longer, further flame because it prevents the fuel mix from burning up before it gets to the target. Never shoot 100% pure gasoline. It is important to wear proper PPE when doing this project. That means long sleeve, pants, jacket, and closed-toed shoes, all made of natural fibers. That means that it needs to be wool or cotton. If you use something like polyester, nylon, or any other synthetic material, it has a tendency to melt and stick to your skin, which is not what you want when you're on fire. For this project, our propellant is going to be propane. That's what's going to provide the pressure and get rid of all our fuel out the hose. But that might seem like a dangerous choice. Propane, after all, is flammable. Well, propane will work as long as we are looking at the fire triangle. The fire triangle says that we need heat, we need fuel, and we need oxygen to start a fire or an explosion. As long as we ensure that there is 0 oxygen in this tank when we start using the system, it is perfectly okay to use propane because there's no oxygen to burn the propane. Typically, you would use something like carbon dioxide, nitrogen, or even argon to pressurize your system, but that's pretty expensive, and I want this to be accessible, something I can go to the hardware store or supermarket, and it's kind of hard to find places that will refill carbon dioxide. So for this project, I'm going to be using propane to excel the system. With that being said, it's important that you flush the system many times over. I did it for 2 to 3 minutes every time we fired, just to ensure that there was 0 oxygen in the tank that could cause an explosion or fire. Now, due to the laws of physics, when a liquid goes to gaseous form, there's an energy deficit, meaning that the propane is going to get very cold and the pressure is going to drop. It won't be able to vaporize as easily. This just means that after you fire, you might go from 150 psi all the way down to 30 psi, which isn't enough to get your stream going very far. So I do recommend swapping out the tanks between firings, allowing that propane to warm back up and get back to a nominal pressure. First off, we're going to have gaseous propane that flows through our adapter and the propane tank. And then it's going to go to a pressure gauge, which is going to tell us what we're operating at. And then there's a big valve that allows us to pressurize the full tank. It's important that we don't fill our fuel far above this valve, just because we don't want fuel going back into the system by the gauge. But more importantly, we need this ullage space. This is important because it acts as a reservoir of pressure and allows us to fire for longer at a higher pressure. The propane tank is able to supply pressure at a set rate, And a way to get around that and to give us more time at a higher pressure, you need this extra ullage space. We're just using the neck of the bottle and the big all valve that it came with to fill it with fuel. Just because I can't find a ball valve or anything with this thread, it's incredibly specific for a reason. So for now, I'm just screwing this on and off, but you could probably find a solution, weld on a ball valve. There are a lot of other options out there, depending on what pressure tank you're using. If you're using a fire extinguisher, you might have more options than I do here with the oxygen bottle. Once our fuel has been pressurized by our propane system, it's important to flush out the oxygen. So we'll have fuel up to this height, and we're going to open this valve, which will allow propane to pressurize the system. We're then going to open this valve, and this is going to allow the propane gas to go from this tube right here straight over and out. This is really important because that means we're flushing out all the oxygen. I often let this run for 3 minutes, just allowing all of the propane to evacuate the oxygen. This might be a little bit of a waste, but in my mind, safety is not a waste, and we want to make sure there's absolutely zero oxygen in this tank that could cause a fire or an explosion. After we have flushed out all the oxygen, we go ahead and close all of our valves. We can pressurize the system if we would like. Now to pressurize and depressurize our fuel line, we have a valve at the bottom here, which allows the fuel to flow out. We have pressure up here, our fuel is in here, and it gets pressed out through the valve at the bottom. This valve at the bottom allows us to pressurize the fuel line. It also allows us to close off the fuel line and depressurize it. I'm using a kit that comes with all the fittings and hose necessary. This is called AN fuel line. You could absolutely use something different, but I was able to get this for free due to a shipping mistake. So this is what I am using here. The important thing is that it's rated for high pressure, but it also is rated for the fuel, so we won't get degraded lines over time. Now this air gun is probably the most sketchy part of the project. It is a high flow air gun from Harbor Freight. We just have a high flow air gun here with the 2 extension tubes and a nozzle. This allows me to be further away from the flame front. I'm also able to connect a BlowTorch here with some U-bolts and rubber grommets. I don't know if that's the best way to do it, it's just how I did it. This gun is not technically rated for the pressures we're using it at, so that of course is a failure point that you need to keep in mind, although engineers often have designed this to be capable of a little more than advertised. There is a safety margin in there. So keep that in mind when you are making this project. Make sure you're using rated parts for maximum safety. Now, if you would like to mount this to your back, I'm using a Scuba harness. It was $30 at Walmart. However, you could obviously make this cheaper if you use a backpack from Goodwill, and you could modify that. You can reduce costs everywhere on this project, whether that's from using a different type of tank, maybe a used fire extinguisher or used oxygen bottle. You could be using a backpack instead of a Scuba harness. There are a lot of ways you can save cost on this project. I have a list down below of all the individual parts I used, as well as good pictures and documentation on the website. However, I'm not going to release a full in-depth tutorial on how to actually build this, just because if you are going to build something this dangerous, you should have the common sense on how to build a project like this. Now, once you have built your project, it is time to go test it. Of course, we were using proper safety precautions the entire time. We made sure there was no vegetation in our area. But with all that being said, let's get out to the desert and let's go shoot some flames.
Basically, we want to just make sure there's zero oxygen in there. Josh, this is when you start recording.
They have evidence of what happened. Oh!
Holy cow, guys.
You don't. Oh, wait.
Hold on. It's looking good.
Go for it. Go for it. Oh yeah.
How many flies?
Yeah, you're good. It's hot.
Oh. 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 Guys. Oh. An unused round. I say we save it.
Keep it at our house and do what with it? I'm not gonna
Shoot it later.
I'm gonna pack it up so like we probably. I mean, unless you guys want to go and want to pay for fuel, they can.
Well,
We don't have to pay for
because if we have all that fuel, we can.
If there's like a shot and a half, probably.